This is the part 2 of 5.2 notes. So this is more properties of logarithms and a little bit more complicated properties than the first. And we use these properties to expand and compress logarithms. Either expand them from one log into multiple logs, or compress from multiple logs into a single log. So if you notice what's going on here, we've got a log of two things being multiplied together. And one of the properties of log says we can take that single log of two things being multiplied and rewrite it as a log of two logs being added together, each piece getting one part of what was being multiplied. And then this one says if you have two things being divided, we can split it up with subtraction. Top minus log of the bottom. Right, log of the top minus log of the bottom. And then the third one says if I have the log of something being raised to a power, I can bring that power down in front of the log. Right. So these are three very useful properties when we're dealing with solving equations and or expanding these things, like we're going to do down here in this example. So they want us to use these properties and rewrite these as sum, difference, or product of logs and simplify where we can simplify. Right. So we're going to use the first 5 properties along with these new 3 ones here. Alright, so this one says log base 4 of 5 times x minus 7. Alright, so using the properties we just saw on the previous page, this is equal to, I've got multiplication, so this is the log base 4 of 5, right, and because of the multiplication I can rewrite that as plus the log base 4 of the second thing that's being multiplied, which is x minus 7. Alright, this one we got again multiplication. Alright, so I can do like I did before, the natural log of the first thing, e squared. There's the multiplication, so I can write that as plus the natural log of the second thing, e plus 3. Alright, now you have to understand this is not, and just like over here, these are not multiplications. This is the input of the log, so we don't distribute this through. Okay, we don't distribute this through. We just have to leave it right here. There is no rule about expanding if it's a sum inside the logarithm. It's if it's a product inside the logarithm. Alright, and we'll mention then a little bit more of that later. Now, notice it also said simplify as far as possible. Remember, natural log of e is the log base e of e squared, and using that third property again, these are the same bases, so we just end up with the exponent. So this is 2 plus the natural log of e plus 3. Alright, nothing we can do about this e, but that e right there, this ln and this e wipe each other out, and that 2 just drops down. Alright, now we got a division symbol going on here, so this will end up being the log of the numerator, x minus 8. Alright, minus, because it's a quotient or division, the log of the denominator, log of x. Alright, and again, can't distribute this log through. Alright, this is the input of the log. So this is just like function notation. We don't distribute it through there. Alright, and then according to that last rule that we saw, we have a logarithm with an input being raised to a power. So according to that last rule, we can bring this power out front and say that this is 6 times the log base 4 of y. Alright, and again, that's as far as we can take it. Alright, so this one we could go a little bit further because the natural log of e to the second power was 2. But really none of the other ones we could do anything else with other than just apply the rules that we have. Alright, last one we got the natural log of 1 divided by something. So we got division. So this is the natural log of 1. And then because of the division, we can say that's minus the natural log of x to the 5th. Alright, now go back to your previous rules. The natural or the log base anything of 1 equals 0. The log of any base of 1 equals 0. So this piece right here is just equal to 0. Okay. Now notice you can use your calculator to help on these that are natural logs and common logs right now. We'll be able to do it for all of them later, but the natural log of 1 equals 0. All right, if you get a whole number out here, then that's what you write down. If you get some kind of decimal, some funky decimal, then don't worry about writing that down. But if you get a whole number, write that whole number down. All right, and then minus, this is a power inside the logarithm, so again this can come down out in front. So 5 times the natural log of x. Right, and then 0 minus anything is just that thing. So negative 5 times the natural log of x is our answer. That's a times dot, by the way. Alright, and then this is what I wanted to highlight to you. This is what I've been mentioning in the previous problems. There is no property of logarithms that allows us to rewrite a logarithm of a sum or difference. Okay, this means that the log base b of x plus y, right, is not at all the log base b of x plus the log base b of y. Okay, alright, that would look like the distributive property, what I was talking about before, and this is not multiplication. This is the input of a logarithm, so this is not true at all. Okay, so make sure you understand that we cannot rewrite one log of a sum as two separate logs separated by that plus sign. Okay, this is just not true at all. Okay, so be careful. That's one of the biggest mistakes people make when they're dealing with logarithms. Alright, let's see how we can do with this. Compressing logarithms means going back the other way. We start off with multiple logs and we come back the other way. So when you're doing this, when compressing to a single log, alright, start with the product property, the power property. Alright, then go to the product property. And then finally go to the quotient property. Alright, and I'll show you what I mean here when I do this. So for part A, let me grab this and put it on the next slide. Alright, so for part A, this says do the power property first. Well, the power property applies here because when I'm going in reverse, this number that's being multiplied by the log goes back up as the power on this base. So initially we'll have the log base 3 of x plus, we're going to put that 4 on top and say this is the log base 3 of y to the 4th power. Okay, so far we've done the power property, so that one's done. Now we go to the product property. The product property applies if you have an addition sign. So what that says is if I have addition of two logs, I can combine into a single log the two things multiplied together. So x times y to the 4th. Alright, now the second one, B. Have 1/2 log A minus 3 log B. So we're going to start again with the power rule. We're going to move these 1/2 and this 3 up to the top. So that's going to be the log of A, log of A to the 1/2 power minus 3 goes up on top of the B, and we got minus log of B to the 3rd. Alright, there is no product rule, there is no sum in here anywhere. So we go down to the quotient rule last, and then we say this is a single log, alright, with a to the 1/2 power over b cubed. Now if you want to, because a to the 1/2 power is the same thing as the square root of a, alright, you're welcome to write it that way, but you don't have to. So, but either one of these would work. Either one of these would be fine. Alright, and then C. Once again, I'm going to start with the power rule, so I'm going to put that 3 up top. So I've got the natural log of 5x minus, the 3 goes up, and I've got the natural log of z cubed. Okay. Now remember, I don't want to expand this. Yeah, I could expand it and say that that's 5, natural log of 5 plus the natural log of x. But we're compressing it and trying to get it to a single log. Okay, so that would defeat the purpose. So I've already got this thing compressed down to 1 log already. I don't want to expand it back out into 2 and then try to get it all back down to 1. That would be silly. So we'll just use what we got here. We got 2 logarithms being subtracted. We're trying to get them into 1. Alright, so we're going to use the quotient rule. So this is the numerator. This is the denominator, z cubed. Alright, and then there's our compressed form of that. Alright, notice with a, b, and c here on this example page, we started off with multiple logs and we ended up with a single log every time. Alright, that's what we're trying to do when we compress logarithms.